and welcome to a course on exam techniques for questions on sequences and series in grade 12. Here, arithmetic and geometric formulae are used to obtain properties of a sequence, such as certain terms, and a difference or a common ratio between them. Furthermore, a sum of terms in a series is obtained through appropriate formulae. Now, let us see how all these come together in a typical exam session.
Given a geometric series defined by terms of t plus 10 and t minus 2 and t plus 4 and so forth, to show that t equals negative 2, define a common ratio firstly by t2 divided by t1 and secondly by t3 over t2. These two quotients are equal such that t minus 2 all divided by t plus 10 equals t plus 4 all divided by t minus 2. Next, multiply both sides of the equation by t plus 10 so that t minus 2 equals a product of t plus 4 and t plus 10 all divided by t minus 2. Next, multiply both sides by t minus 2, so that a square of t minus 2 equals a product of t plus 4 and t plus 10. Simplify using the BODMAS rule so that t equals negative 2. To calculate term 25, notice that if t equals negative 2, r equals 1 over 4, and a equals 8. Use the formula for the nth term to obtain value of term 25. This formula can be found at the back of the question paper on the day of the exam. Substitute the value of a, then r, and then n. Simplify using rules of exponents so that in exponential form, term 25 equals base 2 exponent negative 45. To calculate the sum of the infinite series, use the formula which can be found at the back of the question paper on the day of exam. Substitute the value of a and r. The sum of infinite geometric series simplifies to 32 divided by 3. Given a series that sums to 26,675 and in sigma notation with respect to p ranging from k until 117, with terms of the series given by a formula 4p minus 1. Notice that term 6 equals a product of 4 and k plus 5, and term 14 equals a product of k plus 13 minus 1. The difference between these terms is simplified using the BODMAS rule, so then the difference equals 32. To calculate the value of k, notice that a equals the first term, which equals 4k minus 1, then term 2 equals 4k plus 3. So then the common difference equals 4, and then n equals 117 minus k plus 1. Use a formula for a sum of an arithmetic series. This formula can be found at the back of the question paper on the day of the exam. Substitute the value of n, then a, and then d. Simplify using the BODMAS rule as shown in this slide. Therefore, the sum equals a product of 118 minus k and 2k plus 233. Note that the given sigma notation equals this sum of an arithmetic series. Algebraically, that is a product of 118 minus k and 2k plus 233 equals 26,675. By using the BODMAS rule, this equation simplifies to a quadratic equation. Therefore, the standard equation is given by 2k squared minus 3k minus 819 equals 0. Notice that at least one root of this quadratic equation is irrational. Therefore, a quadratic formula can be used to obtain the roots.
This formula can be found at the back of the question paper on the day of the exam. Note that A equals positive 2, then B equals negative 3, and then C equals negative 819. Substitute these values into the formula. Therefore, since K is an integer, then K equals 21 only. I hope you enjoyed my thoughts on exam techniques for mathematics questions on algebra. Please subscribe to our channel, like this video for more likewise, and share it with like-minded friends. See you next time!